This is Every Challenge Question, Part 39, Corpuscle 1, Chapter 6. It's the matrices chapter. Find a possible matrix A such that A squared is 0 and not all of the elements in A are 0. So we've got A, B, C, D, and then we'll times it by itself to make A squared plus BC, and then AB plus BD, and so on. And we're going to get this. And now we want that to be 0, 0, 0, 0, which means, well, let's just choose some values, right? Let's make A 0 and let's make B 0. Because if we do that, then we can make C whatever we want, and this is still 0. This is 0 because A is 0 and B is 0, so it doesn't matter what D is, because sure. Now this here, A is 0, which is great. This isn't 0 unless I make D 0, which doesn't mess this up and makes this 0. And here, C can be 1, because B is 0, and then D is 0, and then you just get 0. So let's just make C 1, and let's end up with this matrix here, and that will be my contribution for question A. For part B, I want all the elements to be non-zero. So now I have to go back to this situation here, but I'm not allowed to pick zeros. But I think that's okay. Let's choose A to be 1, and then let's choose B maybe to be -1, or C to be -1, and B to be 1, because then I get 1 minus 1, which is 0. Here, I'm going to get 1 times 1 plus 1 times something. So that means D has to be -1. And now I'm just going to hope that these two things work down here. A times C is -1. C times D is +1. That's great. Two negatives there. So that makes a 0. And here, C times B is -1. D squared is +1, and that cancels. And that works as well. So I think that will be good to go. And we're done. Find all possible 2x2 singular matrix. So a singular matrix is when the determinant is 0. Okay. What I decided to do was just write out every matrix that has the numbers 1 and -1, and then just cross out the ones with determinants that weren't 0. So this, I just put all the ones first, and then I chose one of the ones to be a -1. There are, of course, 4 ways of doing that. Then I chose 2 of the ones to become -1s. There are 4 choose 2, 6 ways of doing that, and here they are. And then I chose 3 of the ones to be -1s. There are, of course, 4 ways of doing that. You're essentially just choosing, sorry, that's 6 of them there. You're essentially just choosing one positive one out of 4. So there's 4 ways of doing that, and then it all -1s. And then I just went through them and said, okay, which of these actually have determinant 0? So 1 minus 1 is 0, good. -1 minus 1 isn't, so cross that out. 1 minus -1 isn't, cross it out. -1 minus 1 isn't, and then 1 minus -1 isn't. And then here, -1 minus -1 is, so that's good. This 1 minus -1, I guess, I don't know. 2 negatives make a positive when you times this, so it actually just ends up being 1 minus 1. So that goes away, so that's good. This one is -1 minus -1, which is good. And actually, all of these turn out to be good. Down here, -1 minus, or +1 actually, -1 minus 1, because these are both negative, ends up being not good. And then 1 minus -1 ends up not being good either. That makes 2, and these 4 don't work. But then this one is just 1 minus 1 again, so it works. And you end up with all these ones that I haven't crossed out. Same thing for the next one with 1 and 0. So again, I just wrote out, starting with zeros this time, all the matrices that you could possibly make under this system. So there are 6 with 2 1s, and then there are 4 with 3 1s, and then there's 1 that's 1, 1, 1, 1. And then just run through them. So that's obviously 0, that's 0, that's 0, that's 0, that's 0, because there are too many zeros. This is 0, this is 0. This isn't, that's 1 minus 0, so that doesn't work. This is 0 minus 1, so that doesn't work. This is 0, this is 0. This is 1, so that doesn't work. This is -1, doesn't work, doesn't work, doesn't work. And then this one works, as we saw before, and you end up with 10 of those. Good. Given A and B are 2x2 matrices, prove this. So if A is A, B, C, D, and B is maybe E, F, G, H, then what I'm going to do is I'm going to say det A is AD minus BC, and det B is EH minus FG. And if I just multiply those two things together to get det A, det B, it's this times this. Expand some brackets carefully, you end up with these 4 things. I've been careful to write them all in alphabetical order, or at least what I think is alphabetical order, just because it's going to help me for the next part. Now let's think about det AB. So A times B is this times this, which is AE plus BG, and then the next term will be BF plus DH. What am I doing? AE plus BG, and then the next one here will be AF plus BH, and then I was talking about one down here, then this, and then finally this, and you get the 4 things. Now, the determinant of this is this times this minus this times this. There's quite a lot of expanding to do here. expand it all out. Be careful to write it in all alphabetical order, because then that helps you to spot that this cancels with this. Which one cancels? This one here cancels with this one here, and this one here cancels with this one there. So you get these 4 terms, and again, because they're in alphabetical order, I can spot this one matches here, this one is this one is this, and this one is this. And so therefore those 2 things are the same, and these 2 things are the same, and I think that's that proved.